Let us take a function f of x equal to x square. What we want to do is we want to convert this into a series where the terms are made up of sine and cosine functions. So here we have f of x equal to x square, and that would be equal to this series. Pi square by 3 is a constant, plus 4 times minus cos 1x by 1 square plus cos 2x by 2 square minus cos 3x by 3 square, and so on. When we plot this with, let's say, the first term, just including cos 1x by 1 square, so we get this graph, which is approximating the f of x equal to x square. So this graph is made up of pi square by 3 plus 4 times minus 1 by 1 square times cos 1x. Okay. Now, if we take the second term also, it has got closer to the function f of x equal to x square. And the series has become minus 1 by 1 square cos 1x plus minus 1 square by 2 square cos 2x. And here we are restricting ourselves to the interval minus pi to pi. If I take the third term, I get this. And as we saw previously, if I keep extending it, it gets closer and closer, so that ultimately it converges with the function f of x equal to x square. Now, for that, of course, we have to take it to infinity, the series. That was one example. Now, let's look at another example. Let us say we have f of x equal to x cube. Now, its corresponding series is sum as n equal to 1 to infinity of 2 times minus 1 to the power of n by n times 6 by n square minus pi square times sine nx. With just the first term, we have 2 times minus 1 to the power of 1 by 1 times 6 by 1 square minus pi square sine 1x. With two terms, we end up with this. The first term plus 2 times minus 1 square by 2 times 6 by 2 to the power of 2 minus pi square times sine 2x. Now, if we plot these graphs, what do we get? We get x cube looks like this. And when we plot this with only one term, we get this. It doesn't look anything like x cube. But let's increase the number of terms. 2, 3, 4, 5, 6, 7, 8. I have reached 8 now. 9. And let's actually take it. So now we are in the 11th term, or rather 11 terms. Now 17 terms. Now 26 terms. So if we take it to infinity, it will converge with f of x equal to x cube. So here, this is called Fourier series. Fourier series are used to break up a function into a sum of smooth sine and cosine functions. Fourier series is a global approximation over a periodic interval. The Fourier series general formula is this: f of x is equal to a naught by 2 plus sum as n goes from 1 to infinity of an times cos nx plus sum as n goes from 1 to infinity of bn times sine nx, where n is in the set of natural numbers. So here we have to figure out a naught, an, bn. Because cos nx, given n, we can always figure out cos and sine. So the only thing we have to figure out is a naught, an, and bn. And these are called Fourier constants. And once we find these, we just plug it into this formula. As simple as that. Okay. Of course, to be able to arrive at A naught, AN, BN, we have to do, or we have to know differentiation and integration as well. Now, as you have already seen that we require sine and cos. So let's very briefly look at these two functions in the specific context of this Fourier series. Okay, so let's get rid of this graphs. Now let's look at sine function. Sine m1 times x. Now what is m1? It is just a number, an integer. So if we change the m1, the graph of the sine function changes. More specifically, when it is 0, it becomes sine 0, and we know sine 0 is 0. When it is 1, this is our normal sine x function. If we make it 2, the frequency increases. Okay. Now what we are interested in is the area under the curve. And this we figure out using integration. Integral of sine m1 times x dx over the interval minus pi to pi. And here, when we do integration, the area above the x-axis will be positive and area below the x-axis will be negative. So here, this will cancel this will cancel this, because they are equal to each other. So the overall area would be 0. Now it doesn't matter what the value of m1 is. It will always be 0. Either it will be actually 0 or there will be cancellations. So that was sine m1 x. Now let's look at the next one. That is cos. So again here, if we change the value of m1, the frequency increases or decreases. When it is 0, it will be a straight line because cos 0 is 1. Now what about the area under the curve? Area under the curve here is, can you guess? Height is what of this rectangle? 0 to 1. It is 1. What is this? Length. Length is minus pi to pi. That means it is 2 pi. So the area will be 2 pi times 1, that is 2 pi. Let me actually bring it in. So area under cos m1x is equal to 6.2832. We know this is 2 pi. Now, as I keep changing these values, the area remains 0, because again, cancellations happen. Except when it is 0, it will be 2 pi. Now, let's look at product of sine and cos. What happens then? So let's take sine times sine. Sine m1x times sine m2x. Now here we have two variables, m1 and m2. So even if one of them is there, is 0, then the whole thing will be 0. That is why you are getting a straight line. So let me bring in the area under the curve. But if I change this value of m2 or m1, then we will have some area. But the overall area under the curve would be 0 because of, again, cancellations. What happens when m1 and m2 absolute values are same? Then there will be an area under the curve which is equal to minus pi if one of them is negative. If both are negative, what happens? It becomes pi. Now let's look at the next one. Cos times cos and the area under the curve. So here minus 3, they are equal. So there is an area under the curve. It will not be 0 because there is nothing below the x-axis. So that is equal to pi. Let's change this values. Again, minus 3, 3. Now in case of cos, it will be pi. What happens when this is 0? And let's make this also 0. Then in that case, the area under the curve will be 2 pi. And we need to understand that primarily because Fourier series involves breaking up a function into a series made up of sine and cosine functions. Again, let me remind you, there is a link to a PDF book which describes all these in detail. Please feel free to download it, refer to it. And if you think somebody else will also benefit from it, please do share. That's it for now.